Hello everyone. Today we are going to talk about reverse linked list. Previously, we have also talked about this problem using our recursive solution. It has time complexity of O(n) and also space complexity of O(n) as well. Today we are going to talk about whether we can solve it using O(1) space complexity. So in order to achieve O(1) space complexity, we cannot using recursion anymore. We have to do it iteratively. So naturally, let's say we have iterating through this node, we have arrived at the node 2. If we want to reverse linked list, the natural idea is just try to make this pointer to back. However, if we make this pointer back, we lost the track to the next node, right? So we cannot read to the next node. So the key idea here is at each iteration, we keep the first, we save the next node. So in this example, we save the next node here. And we have our current node is pointing to 2. We also keep track of the previous node. Here we should point to 1. So we point the current dot next toward the previous one. So I'm pointing 2 to 1 here. Now we also iterate through this, doing this iteration, and then the next step is previous moving to the next node. So the previous will be here, pointing to 2, and the current will be pointing to the next. So current will be pointing to 3. And now going to the next iteration, like the next will be pointing to current dot next, so next will be pointing to now. And then let's say this is the last iteration, right? And then in this iteration, we were pointing current to previous again, so 3 will be pointing to 2. And then we move previous to 3, to is pointing to 3. And yeah, this is as the machine, previous will be pointing to 3, and the current will be pointing to the now. Now in this case, current is pointing to now, so the while loop will be stopped. And we're returning the previous node, so the previous will be the new head of this linked list. So here, we also have now looked at the initialization phase. So we just take some like middle state as example to let current point to 2. So let's look at how this initialized. So initially, current is pointing to head, and then previous is pointing to now. So during the first iteration, we also save the next pointing to a 2, which is the current dot next, and then we set current to dot next to the previous. So 1 will be pointing to now here. So this is the initial iteration, and then from here it will move to the this iteration we talked about. So current will be pointing to 2, previous current will point to the next, previous will point to the current, and the next will be the current dot next, which is 3. So in this case, we have pros that it can be initialized correctly from the head node, and it will be pointing to the now node correctly, and it will move to the middle state correctly. And in the middle state, it will also move every step correctly. We will save the next node first, and it will point into the current dot next to the previous node, and it will move the previous node to the current node and moving current node to the next node. And we also have proven that during the tail status, previous will be pointing to the new head correctly as current will be when current is now. So this is the full implementation of the reverse linked list using iterative solution. It has a time complexity of O(n) because it is doing the full iteration of this linked list, which is with what we have to do. But it has a space complexity of O(1), because we're using constant space, and we're not allocating any additional space here. So that's a very concise and elegant solution for reverse linked list using an iterative solution, which has the great benefit of all one space complexity. And the core code is about 10 lines of Java code, which is very cool. So that's all about this solution, iterative solution. If you have any questions, welcome comment on this video. If you like this video, you can sum up. And if you like the channel, you can subscribe to the channel. Thank you.